Chapter 3 is over linear functions, and we're going to start Chapter 3 by talking about rate of change and slope. This lesson is a rather large lesson, so what we're going to do, we're going to split the section into two parts. Your first video is going to be on rate of change, and then the second video for the second night will be on slope. So what you're going to be learning in this section, you're going to learn how to use the rate of change to solve problems, and you're also going to learn how to find the slope of a line. But again, we're going to split those two pieces up. Okay, your Common Core standards: calculate and interpret the average rate of change of a function, okay, over a specified interval. And then you're also going to prove that linear functions grow by equal differences over equal intervals. And again, that goes with rate of change and slope. Okay? So your two vocabulary words, obviously, rate of change and slope. So we'll talk about rate of change in this lesson, and then in the next video we'll talk about slope. Okay, rate of change. If x is the independent variable and y is the dependent variable, then the rate of change is equal to the change in y over the change in x. Okay? Now, again, that should be a little familiar to you. Change in y over the change in x. Y will always be in the numerator. X will always be in the denominator. Okay? So we're going to talk about how to find the changes in y and how to find the changes in x so that you can write a ratio. Let's look at our first example. Use the table to find the rate of change. Explain the meaning of the rate of change. Okay, so here's our table. We have time driving in hours and the distance traveled in miles. So after traveling 2 hours, you have gone 76 miles. After traveling 4 hours, you go 152 miles. And after traveling 6 hours, you've traveled 228 miles. So how do we express this as a rate of change? Okay, well, let's start by looking at our formula. Change in y over our change in x. So what you need to do is you need to look at your changes in each piece. Okay, it says each time x increases by 2 hours, y increases by 76 miles. So what we're doing is we're comparing the change in distance over the change in time. So what you can do is you can pick two values from your chart, okay, and they used 152 and 76. So we're gonna find that change, the change from 152 to 76. Then we're gonna do it with our x values, the change from 4 to 2. So 152 minus 76 and 4 minus 2 gives you 76 over 2, or when you reduce it, 38 over 1. So what does that mean? That means that your rate of change is 38 over 1, or that the car is traveling at a rate of 38 miles every hour. That is your rate, 38 miles per hour. Miles per hour is a rate. Okay, so 38 over 1, 38 miles in 1 hour. Okay? Okay, now why don't you guys try? The table shows the cost of the changes with the number of minutes used. Use the table to find the rate of change and then explain the meaning of the rate of change. So here you have your table. This is minutes used, which is your x, and the cost in dollars. So for 20 minutes, it cost $1. For 40 minutes, it cost $2. For 60 minutes, it cost $3. So start with your rate of change, okay? Change in y over change in x, make your ratio, and simplify it, and then explain the meaning. So go ahead and pause the video right here. Okay, so if we start our change in y, I picked 3 and 2, so I'm going to go 3 minus 2. My change in x, since I used 3 and 2, I need to use 60 and 40. So 60 minus 40. I reduce that, I get 1 over 20. Now there's a couple ways you can write this. I wrote it for every 20 minutes, the cost increases by $1. You could also write it the other way. If you simplified this to 0.05, you could say that it cost 5 cents every minute, and you could also write your answer that way. Okay, so there's a couple different ways you could write that. 20 minutes, for every 20 minutes used, the cost increases by $1, or you could say it costs 5 cents every minute. Okay, and I would accept either answer. Okay, now let's look at variable rate of change. What they're going to do here is they're going to give you a graph. Okay, and we have to interpret the rate of change in a graph. This graph, the graph to the right shows the number of U.S. passports issued in 2002, 2004, and 2006. Find the rates of change for 2002 to 2004 and 2004 to 2006. Okay, so again, our change in Y has to be on top. Here are our Y's. That's your millions of passports. Your X or your independent variable is the time, is the year. Okay? So, we have to compare two different time periods, so we have to do this twice. Let's look at 2002 to 2004. So we're looking from right here to right here. What we're going to do is we're going to take those 2 points, 8.9 minus 7.0. Okay, if we go back to our graph, here we are, 8.9 to 7.0. And the years are 2004 to 2000, or 2002 to 2004. So that's why we put the times there. So when we subtract, we get 1.9 over 2, or 0.95. And what that means is that the number of passports issued increased by 1.9 million in a 2-year period for a rate of change of 950,000 per year. Okay, so here's kind of what they're looking for. This piece right here, 950,000 per year. Okay. Now, here is from 2004 to 2006. Again, what we're going to do is we're going to go back. Let's look at our graph, and we're going to compare these 2 points right here. So 12.1 minus 8.9. Okay? And here's your time period. So when we subtract, we get 3.2 over 2, or 1.6. So what that means then is that rate of change between those 2 years increases 1,600,000 per year, the passports. Okay? Now, what they want to do, it says explain the meaning of the rate of change in each case. So here's their explanation. For 2002 to 2004, there was an average annual increase of 950,000 in passports issued. Between 2004 and 2006, there was an average yearly increase of 1,600,000 passports. So when it says explain the meaning, they just want you to rewrite it in sentence form, what that actually means in words. Instead of having the math part, they want you to write it out in sentence form. Okay, C says, how are the different rates of change shown on the graph? Well, if you look, the different rates of change are shown by, you can tell that they're from 2002 to 2004, and then from 2004 to 2006. From this period to this period, there's a greater vertical change. So it's steeper, which means your rate of change is going to be greater, which was the case. Okay? Now, what I want you to do, use those examples and try to do the same. You're going to do the same thing for your own example here. Now, in this case, however, you can see that this looks pretty linear. Okay, so you might be able to pick up on something between these two time periods here. Okay, so go ahead and pause the video and try A, B, and C out. All right, let's see how you did. We're going to find the rate of change from 95 to 2000. So what I've done, this is a triangle and it's a delta. It means change. So your change in Y over your change in X. Okay, get rid of that. So we're going 9.0 minus 8.1 from 2000 minus 1995. That's a time period of 5 years. And your change in millions is 0.9. So when you divide that out, you get 0.18. So what that means is 180,000 departures. Okay? 180,000 departures. So now when we do this piece right here, okay, change in Y over the change in X, we're going to go 9.9 minus 9.0, and we get 0.9. Our time period, again, is 5 years. and you get the same amount, 180,000 departures. And you can see it should be the same. The steepness doesn't change. So what that means, it has the same slope. It's linear. Okay? Now, explain the meaning of the slope in each case. The rate of change was the same. Okay? That's all you have to say. The rate of change was the same. It changed 180,000 departures per year. Okay? How are the different rates of change shown on the graph? Well, they're the same rate of change. The vertical change is the same for both periods, so the slopes are the same. Okay? There was no different rate of change. Okay? It stayed linear. So from this time period to this time period, the rate of change it didn't change. Okay? So that's how we know it's a linear function. The rate of change was the same. Okay, the other way you can do, the other thing we're going to talk about with rate of change is constant rate of change. Okay? And what you're going to do is to determine if a function is linear, you want to see if it has a constant rate of change, just like the previous problem. The rate of change was the same, therefore it was linear. So you're going to do the same thing. If you go between each one, you can see that the rate of change is the same. 12 minus 6, 2 minus 1. That gives you 6. 18 minus 12, 3 minus 2, again, 6. Okay? The rate of change is constant, therefore it's a linear function. Okay, B. Now look at this one. When you go from this one to this one, 5, from 1 minus 5, and then from negative 2 to negative 10, you get a negative 1/2. But if you go to the next step, you don't get that. You get a negative 5/8. Okay? The rate of change is not the same. Therefore, it's not a linear function. It's not constant. That rate of change is not constant. Okay? Therefore, it's not a linear function. Okay? All right, you've got 2 practice problems. Determine whether each function is linear. So what you're going to want to do, you want to try your change in x over your change in y and see if it's constant. So go ahead and pause the video. Try the next 2 example problems. All right, so what did you get? Did you determine, is this one a linear function? It is, because the rate of change is constant. Let's take a look. How is it constant? Well, from here to here is a change of 5. From here to here is a change of 5. From here to here is a change in 5. From here to here, change in 2. Here to here is a change in 2. Here to here, change in 2. So you can see that the rate of change, your change in y over change in x, your constant rate of change is 2/5. And each time it changes by 2/5. So that's a constant rate of change. If you look here, constant rate, we're changing by 3. Then we change to, we're going up by 6. Then we change to 3 again. Let's look over here. 4, 4, 4. So you can see this piece right here, this 6, kind of throws things off. Okay, it doesn't increase by the same amount. So what happens here is this one is not a linear function because it does not have a constant rate of change. Okay? That is going to be the end of the rate of change video. So keep a hold of your outlines, and then the next video will be on slope. Okay.